All right. Well, it's the top of the hour here, so let's not waste any time. Good morning or good afternoon, everyone, depending on where you are in the world. My name is Jerry Ola. I'm one of the product managers here at Ekahau. If you've joined us for a previous webinar, welcome back. And if this is your first time, thank you again for joining. We hope that you find this webinar informative and insightful. Before we get started, a couple of housekeeping items. You should notice that you're in a listen-only mode, which means that your lines are automatically muted. But yeah, to go ahead and submit a question, locate that questions pane in the control panel there, and submit those questions throughout the presentation. I'll be kind of lurking in the background there and answering those questions throughout the session, and we'll kind of pool some of those together for our Q&A section at the end. So yeah, go ahead and get those submitted as you think of them, and we'll get those answered as best we can throughout the session. Today's webinar topic is going to be on visualizing airtime utilization. We've got Joel Crane on here, one of our technical training manager here at Ekahau. He joins us to present on this very important topic. So yeah, let's stop listening to me chat away here and turn it over to Joel. You on the line?
Yep, sure am. Thanks for the introduction, Jerry. And yeah, like Jerry said, feel free to use the question tool to put those questions in at any time. There also is a chat function. Do we have chat turned on, Jerry? Yeah, we do. We totally have chat turned on.
Sure
So
do, yeah.
if you guys want to blow up the chat section too with your own discussion and stuff, then please feel free to do that. Although just keep in mind that for questions, to ensure that we get to your question, use the Q&A tool specifically instead of the chat. Use the Q&A tool for any questions that you have for us. But if you'd like to make just a simple comment or something like that, the chat is an excellent place to do that. And also, Jerry, throughout this webinar too, I'm going to lean on you a little bit too. If you have a comment that you want to make, if you want to jump in and we can have some discussion and stuff, then I mean, I think that's always fun. So feel free to jump in at any time.
I'll try not to derail us too much.
Nah, I mean, I don't know. Well, we should be good. It shouldn't be too bad. So great. Well, thanks for joining us today, everybody, for this topic about visualizing airtime utilization. Now, this is a topic that's very near and dear to my heart because this plays very closely with spectrum analysis. It plays with packet analysis, and it plays with capacity planning and things like that in Ekahau. And it's a very, very important topic in the world of Wi-Fi. So. Ian says, hey, audio quality is great. Ian, why don't you ask at the end, and we can definitely talk about what the audio setup looks like. I can definitely talk about that maybe a little bit at the end, or we can take it offline, something like that. So really nice for webinars.
Do you have a blog post even about that?
Yeah, you know what I do? If you go to the prestigious blog website, potatofy.com, that's my most recent blog post on there is actually a little blog about what my audio setup is. So pretty inexpensive, actually. You could pick up the whole thing on Prime Day, for which I know we just passed Prime Day, but you should be able to pick up the whole setup on Amazon for, I don't know, probably $120, something like that, depending on what the price is. But the microphone that I'm using here is a Yeti Blue microphone. So go check out the blog on potatofy.com and you can check out a little bit about that. So we can talk about it later on if you guys would like. Oh, cool. Jerry just posted that in the chat, so feel free to check that out. But back to airtime utilization, and just to kind of give you a quick idea of what the agenda today is going to look like. First, I kind of want to stop and talk about what is airtime. What exactly is airtime, and why is it important for Wi-Fi? Before we get into that, we'll talk about the half duplex nature of Wi-Fi and how that plays in heavily with airtime utilization and why that's an important thing to understand for Wi-Fi. We'll also talk about what utilization is and how utilization differs from airtime, and then we'll talk about how to view airtime utilization, how to actually view it in a live environment, and then we'll do a live demo of using both Spectrum Analyzer to view airtime utilization and do some capacity planning as well. And of course, we'll leave some time at the end for Q&A, so feel free to get those questions in as we go, and we'll answer those at the end of the webinar. So first, I'm going to spend just a little bit of time kind of doing a little bit of whiteboarding and talking about the half duplex nature of Wi-Fi. Now, this is probably the most critical, most important thing that you can understand or know about Wi-Fi is that Wi-Fi is half duplex. What does that mean? Ultimately, what it means is that on any given channel at any given time, only one device can transmit. One device can transmit on a channel at a time. So think about this for a second. If you've got an access point and if you've got a client device, I'm going to attempt to draw a little laptop client device with my mouse here. So, hey, I think that's okay for mouse art. If we've got two devices and they're on the same channel, only one of these devices can transmit at a time. If the laptop is transmitting, the access point has to shut up. If the access point is transmitting, then the client has to shut up. Only one thing talks. And when you bring multiple devices in on a channel, well, now everything on that channel has to take turns talking. One thing gets to transmit on a channel at any given time. Now, that means that we have a limited amount of capacity on a channel because time on the channel is limited. When you put too many devices, too many APs on the same channel, all those devices are going to have to contend for access to the medium. Basically, they have to contend for airtime. Only one thing can talk, and ultimately, eventually, you put too much on the channel, and we run out of opportunities for devices to talk. The more devices, the more transmissions we add to a channel, the smaller and smaller our transmit opportunities get until eventually we basically run out of time. Now, speed factors in here heavily as well. If we have an access point and we have a client device, this time let's do a phone because a phone's very easy to draw because modern phone design seems to have resorted to squares or little rectangles. Little glass rectangles is kind of what we're down to as far as phone design at this point. But if we've got a device that's relatively close to the AP, a device that's able to maintain a relatively fast data rate, it's going to get on the air and off the air pretty quickly. Like, for example, if a single stream device is able to hit 72 megabits per second, it gets on the air and off the air really quickly. It doesn't spend a lot of time on the channel. But if we have a device that's really far away, maybe it's kind of like on a fringe area of the coverage cell, we might have to slow all the way down to a slower data rate like 6 megabits per second. Or maybe 5.5 megabits per second, all the way back down, maybe even to 1 megabit per second, which is the original data rate that's the very original data rate that we had in 1997. 1 and 2 megabits per second were all we had when 802.11 prime was introduced back in 1997. If we have to slow down to that legacy data rate, this device is going to consume about 72 times the amount of airtime that this device will to transmit the same amount of data. So that's the important thing to understand about Wi-Fi. One thing talks on a channel, the more devices and transmissions we add to a channel, the more congested that channel gets, and the slower things talk, the more time those devices consume on the channel. It all very heavily plays together, and you can see how they're all factors in this discussion. So let's talk about airtime for just a second. What exactly is airtime? Well, airtime is basically the amount of time that devices reserve to transmit. Whenever a device transmits, it basically sends a transmission out on that channel that says, "Hey, everybody on the channel, shut up for this much time because I'm going to use it to talk." When a device accesses the medium, when it gets control of the air, it basically tells everybody to set a timer. It says, "Everybody set your watches, synchronize watches now. We're all going to be quiet for this much time so that I can talk." That is airtime, and devices basically reserve times to talk whenever they transmit. Airtime is affected by lots of different things. It's the amount of airtime in use is affected by the amount of devices that are inside the coverage cell. It depends on the throughput needs of the applications, basically how often they need to transmit, how much data they need to move across the air, and also the data rate of transmitting devices, how fast they talk, just like we talked about a moment ago. Now, airtime can be measured at layer 2 with a packet analysis tool. Now, I say packet analysis. I mean, what I really mean there is frame analysis. Because in wireless, they're really not packets, they're really frames. Frames contain packets. It's just a minor detail. But you can measure how much airtime is in use by using a packet analysis tool like for example, Wireshark, or you can look at something like OmniPeak or IPA or one of those tools to look and see from a packet analysis standpoint how much time our device is reserving on the air when they make those transmissions. Now, the other side of this is utilization. Utilization is basically a measurement of how often raw radio frequency activity is detected in the air. How often do we see energy in the air? Whoops, bumped my microphone stand. How often do we see energy in the air versus how often do we not see energy in the air? And from that, we can basically get a percentage. How often is the channel being used or utilized? Now, this is affected by same things, the amount of devices in the cell, how throughput intensive those devices are, and the data rates of those transmitting devices as well. So it kind of sounds like the same thing, doesn't it? It's similar, but it's not quite the same thing. Close. And we'll talk about that just a little bit more in a second. Now, utilization can be measured at layer 1. Instead of looking at the packets, instead of looking at the frames, this time we're taking our measurement at layer 1, which is a measurement that we're going to take with a spectrum analyzer like the one that's on board the Ekahau Sidekick. That's going to take a look at the raw radio frequency activity in the air, and that can tell us how often that channel is or is not being used. That can tell us how often they are or are not being used. So let's compare these two really quick. Let's think about how these two might compare. Utilization is a layer 1 measurement, so we're measuring raw radio frequency activity, and it's the total amount of time that energy is detected in the air. How often do we hear something versus not hear something? Now, here's the big thing to keep in mind. Anything can cause utilization, whether it's a Wi-Fi station or otherwise. So it could be a Wi-Fi device that causes utilization. It could be a cordless phone. It could be a wireless video camera. It could be a microwave oven. Anything that chirps in the spectrum can cause utilization. Airtime, on the other hand, is a bit more specific to Wi-Fi. Airtime is a layer 2 or packet measurement. So this is when we look at how much time devices are reserving to transmit. And really, for the purposes of this discussion today, when we're talking about Wi-Fi, airtime is really more of a specific to Wi-Fi devices. So just keep that in mind, that there is a distinction, there is a little bit of a difference between those. But when you really stop and think about it, for what we're doing with Wi-Fi, we want to know how busy is a channel. There's absolutely nothing wrong with saying how much airtime utilization is there. When you look at these two, utilization affects airtime, airtime creates utilization. They're very, very closely linked. Not exactly the same thing, but very, very closely linked. So, and a very important measurement to take. So, are they the same thing? Well, sort of. And I think that they're close enough that if somebody says airtime when they mean utilization, and if they say utilization when they mean airtime, yeah, that's totally fine. It's just like earlier when I said that when I use the term packet analysis, well, it's really frame analysis, but we all know exactly what we're talking about when we say wireless packet analysis. So I want to stop and talk for a minute too about how Ekahau displays this information. Then we're going to jump into a live demo and actually look at some airtime utilization. So in Ekahau, we've got a tool called the RTFM. That's the real-time frequency monitor. So the real-time frequency monitor in Ekahau displays live or captured spectrum analysis from the Ekahau Sidekick. So there's two ways that the RTFM displays airtime utilization. First off, it does it by color. So you can look at a graph. This graph here, and I'm going to show you this live, is called the density view. And this is going to show us what is happening in our environment right now from a raw radio frequency perspective. So you can look at the spectrum by color and see how busy each frequency is on our chart. So for example, here on channel 11, we see that there's this kind of curve shape and it's kind of a yellowish red. That means that slice of spectrum is busier than this guy over here on channel 5, who's kind of this greenish yellow. That one's not talking as often, and that's even talking a lot less than these spikes that are over here. So color indicates how often something is talking. We can also look at it from a raw percentage standpoint. So we can look at a percentage in Ekahau, and that's going to basically give us an average utilization across a 20 megahertz Wi-Fi channel. So for example, this capture of this chart was taken at the exact same time as this capture of the density view. And so if we look at channel 11, well, channel 11 is sitting at about 22% utilization on that channel right now. It's being used 22% of the time, which means that roughly 78% of the channel is still available for use. And so we're only using 22% of the time on that channel right now. Whereas you look at channel 5, now first off, this guy's on channel 5, bad place to be, but that's another discussion for another day. We're only seeing about 5% utilization on that channel. So with the spectrum analyzer, with the real-time frequency monitor and the Ekahau Sidekick in Ekahau Site Survey, you can quickly look at that and know exactly how busy a channel is. Not only is this something that you can look at live, but you can look at a survey as well to get an idea of what the spectrum looked like when you were there at that specific point in time. So what I'd like to do now is let's peel away from the slide deck here for a second, and let's take a look at Ekahau Site Survey with the Sidekick, and let's take a look at some live spectrum analysis examples here. So let me get switched over here, and whoops, 2 PowerPoints open at once. Thanks, PowerPoint. Okay, so here we go. We've got just a blank project file in Ekahau, and don't worry, here in a little while we will go ahead and put something in this project file and start doing some mapping and planning. Don't worry, that's going to come here in a little bit. So, hey Jerry, can you
your PowerPoint?
Yeah, I'm having some trouble. I thought I would take advantage of that cool new feature that the guys at Zoom showed us earlier this morning, and it failed. It just did not work. So hang on a second. Let me see if I can get that fixed. And okay, there we go. Should have stick with what I knew on a live webinar. Shouldn't be trying new things in front of in front of a bunch of people. So, oh well, that's what happens.
I'm still seeing your PowerPoint slideshow. Oh, there we go. Okay, just updated.
Yeah, there was one more button I needed to click. So let's see. What was our hashtag since we just switched over to Zoom from another video conferencing solution? It was hashtag blame Zoom.
Blame the vendor. Yeah.
Blame the vendor. Yeah, definitely the vendor's fault. Not user error. Definitely not that at all. Okay, cool. So let's go ahead and talk about the real-time frequency monitor here in Ekahau. Now you can pop it up from the bottom and get kind of this built-in view down here. But what I like to do is click this little pop-out button and make it its own window. So that way we can kind of get a full screen look at what's going on. And Jerry, if there's anything in here that you think we should point out, as I'm explaining things, then man, you just jump right in. I'm sure you've got some great insight that you can add here. So let's go down and look at the 2.4 gigahertz band first. And we can see that there's a bunch of networks that the Sidekick is detecting here. So this is all the basically passive scanning data that the Sidekick is bringing in here. But it's also bringing us the background information here, which is the spectrum analysis data. So the big things that we can see right now is that if we look at channel 11 is being used. It's about 7 to 8% of the time. Now, remember, this is an average over that 20 megahertz channel. Let me draw on that really quick so you can see what I'm talking about. On this 20 megahertz channel, and on top of that, it's an average of a time span, which in this case is 5 seconds. So when we look at this, when we look at 5 seconds worth of data, that's what we see over that 5 seconds, over that 20 megahertz channel. Now we hit about 12% utilization there for a second. So it's moving around quite a bit. If you want to stabilize this and get a little bit more of a historical look, we can just grab a bigger time span. So now this is over the last minute. The average over the last minute has been 9%. Now notice that down on channel 5, still doing pretty much the same thing as when I grabbed the screenshot for this. It's sitting at about 3% utilization. So that's not a very busy channel at all. But let's go take a look at the 5 gigahertz band. What's going on up in 5 gigahertz here? So let's get switched over to that real quick. And so here we've got my access point right up here on channel 100 and 104. And you know what I'm going to do? I'm just going to run a speed test on that. And let's see what happens to utilization when we do something bandwidth intensive, like run a speed test. So I'll just zoom in on this a little bit. And so speed test is looking for a server, and bam, off we go. So watch our utilization. Oops, I need to grab a shorter time span. I grabbed too much of a time span. So let's go back down to 5 seconds here. And then we'll zoom in a little bit. Oh, I totally botched that. I messed that up pretty bad. So we'll run another one here in just a second. But you can see on my upload test that we're hitting about 21% utilization, something like that, as we perform the upload. Now, my upload pipe here isn't very big. I'm only able to hit about 5 megabits per second. This is a DSL line. But the download, we should be able to hit a much higher utilization on the download. So let's run that one more time. And we look at channel 104, and we're hitting about 57, 58, 60% utilization, something like there. You can see how the spectrum turned that dark red to indicate that spectrum is being used heavily. So in your environment, you can walk through with a spectrum analyzer on the Sidekick, and you can get a real-time look at how busy your channel is, how often your channel is being used. Hey, Jerry, what do you think? Should we go ahead. Yeah.
Yeah, one thing I noticed while you were talking through that speed test happening is when we started seeing that spectrum utilization get above that 50% threshold, your audio, it wasn't terrible, but I could start to hear some little blips, right? You could tell there's some delay happening there. Do you want to speak to that at all about these percentages and real-time applications?
Yeah, for sure. So doing something, that is a great point. I'm really glad that you brought that up. When we're doing something that's kind of I don't know, think like web browsing or something like that, a heavier utilized channel is going to be just fine. We're not going to have any trouble at all on a channel with heavier utilization, because when you're loading images on Facebook, it's okay if we have to load those images a bit more slowly. The user, they might notice a bit more slowness in general, but it's not a big deal. Whereas when we're doing something like voice over IP, which is essentially what we're doing right now, right? With Zoom, this is all voice over IP. We need to make sure that we have the ability to deliver Wi-Fi packets or packets in general, really, at a consistent rate. We need to deliver them reliably and consistently. So when you think about, okay, well, what's an acceptable channel utilization? For most applications, about 70% is the limit. Once you hit around 70%, then that's about where things kind of start to break for general Wi-Fi usage. That's where things kind of, what's that?
For data. Yeah.
For data, for moving data in general. Now, I would say, Jerry, that I would think that there'd probably be some different opinions around that. Some people might say 60, some people might say 80, but I don't know. Do you think 80% for just general data usage is kind of the limit for a Wi-Fi channel?
Yeah, as a rule of thumb, my percentages usually go for, if you're seeing 80% or less spectrum utilization on a channel, it's going to be sufficient enough for general data usage, loading websites, sending and receiving emails. Yeah, there might be starting to be a little bit of delay in things of, it take an extra second to load a web page, or, an extra couple seconds to send an attachment type of thing. There's going to be some contention there, right? So it's going to take a little bit longer, but from a user experience standpoint is what we're talking about. Users are still going to be usually pretty happy when they're on a channel and just doing data, not real-time applications like voice and video, but just doing data is that, around that 80% mark. Anything above that is where you're going to start to have a bad time from a user experience standpoint. Pages are going to time out, emails aren't going to send or receive, you may have to try a couple of times before they're going to come through. It's going to be a bad user experience when you start to get above that, especially if it's sustaining, 70, 80 plus percent utilization. But yeah, voice, I would agree with that. 50% utilization. When we talk about this utilization being 50%, if you're above 50% utilization, that means half the time there's contention to the point where it has to defer its communication, right? And when you're talking voice in real time, if it's 50% utilized, that's a significant degradation in that communication.
Yeah, absolutely. For something like carrying human voice, timing is so important. A Wi-Fi device can't wait to it literally it cannot wait very long to transmit a voice frame or receive a voice frame. We have to get those delivered quickly, reliably, and in a timely manner. So we need to keep the channel more open for those transmissions. Maxim in the chat says more than 50% will impact voice performance. He said we tested that with Vocera badges, and so absolutely, once you exceed 50% voice, it's not going to be a good experience. So that's kind of that kind of makes you think about design requirements when you're designing your network. If you're just doing general data usage, up to 70% utilization is probably okay. But for voice, we really can't exceed 50%. And I think that's a fairly standard. I think that's fairly standard across the industry. I think that's kind of a widely accepted thing. Somebody might have slightly different numbers, and that's okay.
Yeah, and I know for me that was kind of a light bulb moment, right? When I was trying to wrap my head around some of this kind of stuff is, when I first started looking at Spectrum, I'd look at a channel and I'd be like, I don't know why these users are having problems. We're only, using 70-80% of the channel. There's still 20% there, right? But that's not the reality of the way that we look at it. It's not a 100, your target isn't 100%, right? You don't want to see that utilization being, hitting that 70-80% and sustaining that. That's a bad experience.
Absolutely. So, well, hey Jerry, before we leave the spectrum analysis thing, do you think we should plug in the camera just for fun while we're here?
Yeah, me and Steven did a fun little demo with that yesterday with a 2.4. I was on a 2.4 only radio and fired up a 2.4 camera, and we did the same thing with degradation of the audio quality, and actually try to get mine to disconnect altogether, but weren't able to do that. But we're able to at least see that. So let's see if we can replicate that live here.
Yeah, well, as a wireless engineer, I don't know. I have decided to not use Wi-Fi for this. Now, I am going across a point-to-point link to get out to you on the internet, so there is that. However, it's up on the roof of my building, and we can't even see it from here at all. My camera doesn't even touch it, but I am connected via Ethernet. So unfortunately, I'm not going to disconnect myself here unless I literally unplug the cable, which is pretty much what you do if you plug in wireless video camera that runs up in the 5 gigahertz band. This is about $22 on Amazon, and I think its intended purpose is first-person view drones. And oh boy, it looks like the battery just died, and when it did, it really went crazy there. Let's switch batteries real quick here. Of course, if the battery is going to quit, it's going to be when we're doing a webinar. It would not be, when I was doing anything else. It's going to be in the middle of a live webinar. And so, what's that?
It's camera shy.
Which is kind of funny considering that. Yeah, I was going to say that's kind of funny considering that it is a camera. So let me get all the adapter cables here. There's like a cable to plug into a cable to plug into a cable, and power. There we go.
Do you have an active test going right now as well, like a ping test or something? If you flip
I don't think I do. And you know what? Unfortunately, it's going through. I'm not going through my Wi-Fi adapter. I am going through Ethernet. So.
No, we won't see it.
Yeah, we probably won't see that effect there. But what I did, and I wish I'd thought to set up for that. What I did want to show though is look at the utilization of that camera. So remember, this is an airtime usage because this is a layer 1 measurement. This is utilization. But what we're seeing here is that channel is being basically consumed by that camera. Basically, any Wi-Fi device that attempts to transmit on that channel, it will do an energy detect on that channel and go, oops, something's talking, and it'll just back off, and it will just continuously be quiet. So yeah, that's what an analog device can look like, and it can absolutely take out a channel on your network. So watch out for that. So another thing I want to talk about really quick here is mapping this data. If you see something like that on your network, what do you do to find it? How do you track that thing down? Well, Jerry was kind enough to go do a quick site survey of a network. Jared, I'm sure you recognize this one. Do you want to talk a little bit about this environment and what you were doing here?
Yeah, I mean, it's a pretty basic survey is what we start out with. And if you flip to the signal strength view, your typical kind of starting point, right? Everything looks green and pretty and, healthy, right? So we've got good signal strength throughout the whole environment here. If you actually hit the little graph icon there, you can see kind of a breakdown of, what that looks like in the top right corner of the little graph to show the percentages of signals. You can see across the board, it's going to be a pretty solid signal on all the across the board, right? Hit the little graph icon in the top right of the map there. Sorry.
I'm sorry. I was like, what are you talking about? And then,
I should have said visualization statistics.
And I would have been like, oh, I know exactly what you mean. I was hunting around panicking going, what is he talking about?
So here's what I could have used my annotation feature. But
You could
yeah,
have.
here's the dB values is what I wanted to kind of reflect on here. This is your pretty typical. This is a good Wi-Fi environment, right? And we're seeing the majority of our signals around -45 to -50, with the highest signal strengths measured at around -40, -30. Maybe if you're standing right underneath the access point and the power level's turned up as high as it goes, but you're typically not going to see anything greater than -30 dBm. And the reason why I wanted to represent that first from a power level standpoint is that can be really helpful to know if you have some type of interference, right? Because now we know that our Wi-Fi is operating at -30 roughly or less. If we go to something like spectrum channel power, we can filter out essentially the Wi-Fi signals and say, show me anything that's talking louder than the Wi-Fi, right? So under spectrum channel power now, I can take my sliders there and we can crop out anything that's less than -30. So yeah, let's slide that over to -30 and filter down to anything that's not. And notice where the access points are in the building, and that the interference that we're seeing, or the energy that we're seeing there, is nowhere near the source of our actual, where our access points are physically located in the building. So there's another good clear indication of where the source of the energy is coming from.
Oh my gosh,
Yeah.
Jerry. I've demoed this thing many times now, and I never made that correlation of, look, it's not near the access points before. So I just learned something.
Yeah, and the other thing you can obviously do too is look at the channels, right, and see if there's any correlation between the channels that your access points are on and not. If you hover your mouse over that now red blobs that we have there, we can see do the channels match our access points or not. If you hover more over, like the survey path area, you get the details.
Oh, it's the survey path that you got to get.
Sorry. Yeah. Then you can see the actual details of what the channel utilization is. And here you can see 132 is being lit up at -24. And then we have 153 also at -50. But both of our access points in this environment are nowhere near those channels. So we can also kind of, subtract that from it as well.
Yeah, they're on 52 and 36. That's nowhere near, what was that channel, 132? So
132 and 153 are the hottest channels that we're seeing in this environment.
So you know what I think?
That down further.
Which do you want to filter it down by channel a little bit and just look at channel 132?
Sure. Yeah, if you want to, real quick, and then we'll kind of correlate and tie this all into the utilization component of it as well. So we're seeing really high energy. And let's drill down into the energy piece of it first, the actual transmit power of these devices. But then once we have that information, we can drill down into the utilization of that as well.
So let's go look at channel 132 and see, we can basically, that's not cooperating with me. Let me try again here. As soon as you get on a webinar, things do not cooperate. So channel, I'm going to be quick. Man.
It's not
what's going on? Yeah, it's Zoom. Definitely Zoom's fault. Okay, I'm just going to keep my mouse over that and scroll. There we go. So yeah, when we look at just channel 132, it's all focused right there. Jerry, what was the next thing you wanted to point out? I feel like I interrupted you there. Go ahead.
No, so now we've kind of gone down the rabbit hole of the energy piece of it. So we're seeing the transmit power of this device. We've kind of narrowed it down to this interfere, which we've already flagged on the map as a video transmitter. But now we could flip to from the spectrum channel power to the spectrum utilization, and we could drill down into that. Now we could either flip to it on the visualization piece of this and look at it from the same point of view on the spectrum utilization, or we could look at the survey inspector piece of it, right? So let's actually first flip back to the spectrum channel power. So we have that view on the map pulled up, and let's look at now the details from a utilization standpoint, so we can kind of look at both of those things together.
So are you thinking of using the I'm blanking on the name right now. It's the survey inspector. That's it.
Yes, exactly. Yep.
Looking at things with the survey inspector?
So yeah, let's pick a spot along the survey path there. Maybe kind of start a little further away from the interference source. And we know we're isolating channel 132. So why don't you zoom in a little bit on that part of the spectrum there? That's good. And then let's look at the channels tab, because we care about utilization, right? That's what this webinar is all about. So now we can scroll down to that channel 132, and then we have all of our views here now kind of focused in on that channel 132 to really isolate this interferer to understand what it's doing to the environment. So you can see where the ball is along the survey path. if you click on the little, I like to click on, you can do this a couple of different ways, but I like to click on the jog dial, as I like to call it, there on the time slider. And I'll actually use even your arrow keys, right? So you can use your left and right arrow keys to really rewalk, basically like a video game, right? We're playing Pac-Man here. And we're
Wonka, 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 wonka.
Exactly. Need some sound effects to go with
We
that.
need a, man, I hear a feature request coming right there.
So yeah, that's one view that we can use to really step through this, and we can see as we get closer to that source of energy, our utilization is increasing, but still it's not drastic right there. When we're right on top of it, look at that. We can see it jump up to 26% utilization on that channel 132. So notice that, yeah, this is not a super high power transmitter, but it is using a good amount of utilization on one of our Wi-Fi channels.
Yeah, and that's going to absolutely impact the performance of that channel. So I think the big takeaway from something like this is that when these devices pop up, they eat away at your capacity, because they're either going to eat away a certain amount of potential airtime on a channel, or they'll just wipe the channel out entirely. Now, as I look at this, Jerry, you got to correct me on this one if you think I'm wrong, and I'd like to get your thoughts on it. But the spectrum utilization here is, if I'm understanding this correctly, is 26% is the average for that entire 20 megahertz channel, which is something like that entire width right there. Whereas when we look at the core of this signature, it's red and black, which is basically showing 100% utilization. So,
yeah, but not across the entire 20 megahertz. You're exactly
right.
Yeah.
Now, I think that the way that a wireless chipset is going to treat this is that if they do an energy detect on this channel, I think that they will see that talking, and I think they will simply back off and not transmit. I'm pretty sure.
100%. Exactly.
So,
yeah, exactly
so that's why I'm glad to hear that I'm right on that. It feels good to be, right. But what I always do is I kind of think of this as like, this is important because this is the average for the whole channel, right? This is giving us the average for the whole channel. Looking at the color is equally important, because that way we can identify at a single point what is our utilization, and that's going to affect that entire channel from a Wi-Fi chipset standpoint. If they see heavy utilization, they're not going to transmit on the channel. Go ahead.
Sorry, I didn't mean to cut you off there. But the other thing I would also highlight with this that was really eye-opening to me is that notice how that utilization is significantly increased when we're near the source of the interfere. Why don't you step back out a little bit? Yeah, a little ways away from that. And notice now we're still seeing some utilization once we get outside of that kind of path of totality there, we're further outside of it. Yeah. You can see that utilization definitely drop. And what that indicates to me is that, as long as I'm a certain distance away from that source of interference with my receiver is the important part. So whether that's the access point or the client, this is going to be much less devastating than if I'm within a couple of feet. Like if my access point, for example, is in that consultation room number 4, and we're trying to use that channel or a nearby channel, it's going to have much greater impact to that receiver than if I was in the room next door or anything like that. So that's why I think it's an important step in the design process, even of when you're picking out where your access point should be installed in a building, to understand what the RF environment looks like and where these potential sources of interference are in the building, to design potentially around those. Either remove the interfere if possible. A lot of times that's not an option. Maybe that needs to stay where it is, and you can't change the channel or anything like that. So we need to design around it from a channel standpoint, and design around it from a physical AP location or potential client location standpoint. I don't want to put it right next to the source of that energy.
Absolutely. That's a great point. So let's say that this camera or whatever it is completely unremovable. We cannot remove that. It is critical for business functions. And so is this one. There's another one here, a little hint on 153. If we find those there, then when you perform your design in Ekahau, you can use the channel planner, and you can basically, well, I changed my view, but I think it was 132. We could take 132 and 136 out of our channel plan, as well as 153, and essentially design around that. So we have essentially performed some spectrum channel planning to accommodate those devices if we're unable to remove those. So cool. Well, what I'd like to do now, Jerry, is I want to switch gears just a little bit here. And so, okay, here we go. I'm going to attempt to switch back to PowerPoint. So let's see how smooth it is, how this goes, and how was that? Was that a pretty seamless transition? That now we're back.
Beautiful.
All right.
Perfect.
Very cool.
You nailed it.
So, nailed it. Okay. So one question that I have is, well, what about planning? And the response to that is, well, this is an Ekahau webinar. Of course, we're going to talk about planning. Duh. I mean, that's what we do, right? We plan, we survey, we do all this stuff. So I want to talk about planning for a minute. In Ekahau, you can utilize the capacity planner when you're doing a virtual design for a network to basically determine how much airtime is going to be utilized on each channel on each AP. And you can use that to determine how many access points you're going to need, how big your cell sizes need to be to accommodate all those devices. So basically, here's how it works. We're going to start with an input, and the input is going to consist of the amount of clients that you have. So how many clients you've got. Like, for example, here we've defined 50 of this type of client. What the capabilities of the client are. For example, these are some laptops with nice 3x3 chipsets. Keep in mind that different clients have different capabilities. My Android phone, for example, on a 40 megahertz channel can only hit, I'd have to look at a table to look it up, but I think on a 40 megahertz channel, it's going to be something around 150, 170 megabits per second. Not as actual throughput, but as a signaling rate, how fast it can transmit. My MacBook Pro, on the other hand, with its swanky 3x3 adapter, well, sitting pretty close to my little 2x2 AP here with a 40 megahertz channel, it's able to hit a transmission rate of 400 megabits per second. So different clients have very different capabilities, which determines how quickly or not quickly they can transmit. So we're going to plug in our amount of clients, what the capabilities of the clients are, and also the application throughput needs. What kind of throughput we need to achieve for each one of those clients on the network when the network is at load. Then Ekahau can calculate our airtime usage per coverage cell. So let me demo that really quick. We're going to just basically do a quick design, almost from top to bottom here, so you can kind of see, what that process looks like. So seamless switch number 2. Does it work? Oh, look at that. That went, no, did it not work? Or did it?
Nope. Still hanging on the PowerPoint slide.
New share thing.
Yep.
Okay, come on, Zoom. Don't let me down. Did it work
there
now?
It goes. Yep, I see it.
Okay, we'll get this. It's totally, it's Zoom's fault, everyone. Just so you know, that is Zoom's fault. Okay, so let's do a quick design. This is going to be a very, very quick design because I want to get to that point where I can show you what this looks like. So I'm just gonna bring in a CAD file really quick so that Ekahau can automatically draw some walls. So I'm gonna switch to the model layout view, which kind of gets rid of all the extra print stuff. So we'll open that up real quick, and then we'll go through and tell Ekahau what this building is made of. We'll say that the doors are a 6 dB solid wood door. We'll say the elevator shaft is a 30 dB elevator shaft. We'll say that the exterior walls are, I don't know, let's do some brick walls around the outside. And then for the stairwells, let's line those with a 5 dB cinder block wall. And then for the interior walls, we'll do a 3 dB drywall. And then for the windows, we'll do a 3 dB exterior window. Okay, so we've got all that defined. So we'll hit import. And now Ekahau is going to show us some very useful messages about exactly what it's doing right now, such as following the white rabbit. You want walls? We've got walls. Hashtag blame Jake. Reading Lee's article. I don't know. What's your favorite one that's in here, Jerry?
Oh man, it's too hard to pick. I actually just like seeing that every time there's like a new update, there's new ones added.
Yeah. Negotiating a race. I think my favorite is accelerating the DeLorean to 88 miles per hour. But there's only 2 that are true in there. Saving 16 hours of mouse clicking and wasted 80% of our developer resources to write these. Those are the only ones that are actually true as far as I can tell. So. All right, cool. So we've got our design here. So what I'm going to do is I'm going to define an area, and we're going to basically tell Ekahau what our capacity requirements are inside this area. Now, if this was a real design, if I was, really going to actually do a real design, I'd go through and get all those, little nooks and crannies and stuff. I'd make this look nice. But for what we're doing today, this is fine. So I'll double click to end that. And now I'm going to right click on that and hit edit area. And we can give that a friendly name. Like maybe we'll just call it general coverage area. and we can specify how many devices we have in this building. So let's do 50 laptops and give them each 10 megabits per second. Let's do 50 smartphones and we'll give them each 4 megabits per second. And let's do 50 tablets and we'll give them 4 megabits per second as well. We can do a totally custom device too, just for fun. Let's do one totally custom device here. I'm going to go and configure a new device profile. And I just got a new phone. Jerry knows I'm really excited about this. I just got a Nokia 6.1, which is fun because it kind of plays back to our Finnish heritage as a company. And this phone was designed like, I don't know, a mile. I'm sorry, like a kilometer away from our R&D over in Helsinki. So, I'm hoping that it gives me some like props with developers over there that I have in Nokia. We'll see. So this supports 802.11n only. It does not have an 802.11ac chipset. And it supports 40 megahertz channels. We just saw it use a 40 megahertz channel when we did the throughput test with it. And it's a single spatial stream device. Then we can define really exactly what my requirements for this phone is from a throughput standpoint. So let's make a new profile called Joel using his phone. And let's add some applications to this. So I don't know, what do I do with my phone? Well, sometimes I stream Spotify. Premium? Are you kidding? I'm way too cheap for that. We'll use the free one. And let's say that I also do some normal, we'll do some normal email usage. And let's also throw a voice over IP application there. Let's do some Wi-Fi calling. And I have been enjoying Wi-Fi calling on this phone quite a bit. It even works great across my point-to-point link. So pretty cool. All right, so we have defined our requirements. And so now we can go through and we can start placing some APs. And so I'm just going to, it looks like we've got an MR42 selected here. So we'll just go ahead and use that since that's kind of what I've already got selected here. So I'm not being very scientific about this. I just want to get some APs on the map so we can take a look at what our utilization is going to look like for all these access points here. Jerry, any thoughts while I click all over the place and paint coverage around on the map? I just randomly like threw something at you and said, "Hey, Jerry, talk for a second."
And I just realized I was muted. And then
nice.
Yeah. Okay. So I was going to say you should be using the coverage planning feature.
Oh, you're right. I should have used that. Whoops. Yeah, like that. Pretty cool. Alive.
Saved like
half the time. Yeah, that's true. It would have been a lot quicker. Okay, so now that we've got all of our APs placed, I'm going to do a quick channel plan on these. They're all on the exact same channel right now, which means it's just one gigantic contention domain. So I'm going to run the channel planner here and let Ekahau sort that all out for me. And when I look at my requirements, I'm meeting my network requirements on 90% of my floor plan. Nailed it. Pretty good. So we'll call that good. But let's go take a look at our capacity health. How are we doing from a capacity standpoint? Ekahau is going to calculate based on all those devices that we've plugged in, based on what kind of data rates they're going to hit. It's going to calculate how busy each coverage cell is going to be, how much airtime is consumed inside each cell when the network is at load. And as you can see, this AP in the lobby is failing to meet our capacity requirements. Since we have a voice application, which is just me on my phone, we are hitting 54% airtime usage inside this coverage cell, which is failing our 50% limit. So we can get a bit more visibility into that if we switch to airtime utilization. This will kind of give us a red to green look at airtime utilization across our network. This one being the worst coverage cell, this one over here being the best. We're only seeing about 26% airtime utilization there. We can even layer areas if we want. So let's say that this is a conference room and we want to specify specific requirements for that room. We can go rename that. Oh, I should have turned off the automatic refresh before doing that. Whoops. So we'll right click on that and hit edit area. We'll call this conference room. And let's specify some additional requirements. Let's do 15 laptops in here at 10 megabits per second. And let's do 15 smartphones in here at 4 megabits per second. I'm basically just trying to get this to break because I want to see some increased utilization by layering another set of requirements on top. And there we go. If we look at that coverage cell and we hover our mouse there, now we are hitting 61% airtime utilization there. So we are failing to meet our requirement. In fact, 61% in 2.4 and 5 gigahertz, we're hitting 100%. So yeah, we might need to back off our requirements or reconsider our network design a little bit here to account for that. So,
and if you want to drill into some of the details, Joel, flip off, either 2, 4, or 5 there. Let's look at just one band at a time, and we should get some more details, and more breakdown information, right, of what exactly is going on in that area.
Right. So if we hover our mouse here in this one, it looks like the laptops are consuming 55% or have the potential to consume 55% of the airtime. My Nokia 6.1 is using 0. So, it's not using hardly anything here at all. But the laptops, the tablets, and the smartphones are adding up to 100% airtime usage there, which, as we know, is not going to work. It's going to fail quite a bit there. And you can even see which specific application is consuming that. In our case, it's our generic, very heavy SLA, which is consuming the majority of the airtime. And so if you plug in your individual applications here, you can get a breakdown of which applications are using what percentage. So John Hurd has a question that I see pop up over here. He says, are the capacity calculations assuming that all devices are talking at the same time? Yes, John, the calculation is assuming that the network is at load. Everyone is using these applications at the same time. So it's kind of like planning for a worst case scenario, but that's what we want. We want to determine, okay, what do we want this network to be able to handle? And then we design the network up to that point of what it can handle. So
yeah, and that's a good point. Is we didn't talk about you can actually, as a usage standpoint, specify maybe you have 50% of your clients just associated and then 50% active. You can define that in the usage, so you can specify as a usage as a association only.
Yeah, so if we say that those, if we do 50 smartphones that are just associated, we could even split this in half, 25 that are just associated and 25 that are pulling 4 megabits per second. You'll see our calculations are going to change a lot now, because now we're just looking at the association and the little bits of airtime that'll consume, which is not much. And you can see that pretty much across the board, we've seen a pretty drastic decrease in utilization here. So
hit that visualization statistic graph again, and let's take a look at that as well. And you can kind of see over across the board here now, the majority of our areas are going to be in that 20 to 30% utilization range. And mainly what I'm looking for when I'm looking at this is, if I know I need to support a voice over Wi-Fi deployment in the entire environment, what percentage of area is going to have a bad time when it comes to that? And, we can see right now, the majority of the areas are going to be good. They're all under that 50%, other than this 5.9%. About 6% of the area is going to struggle to do voice over Wi-Fi, consistently.
Yeah, so we can even determine where it is and is not going to work based on our requirements right now. So cool. Well, Jerry, I think what I want to do now is let's kind of move towards Q&A and things like that. Just one more thing I want to talk about real quick before we jump into Q&A, and I am attempting, is the third time the charm? We will find out.
Perfect.
Did that work?
No, it did. Worked beautifully.
Nice. So if you want to check out Ekahau a little bit more in depth, then you can request a demo from either Nick or myself. These are personalized one-to-one demos, and of course, absolutely no charge on that. And we'd love to have a conversation with you and show you a bit more about how Ekahau works. So both Nick and myself would be more than happy to do that. We've also got some awesome training options available. My favorite one being the Ekahau Certified Survey Engineer course that we offer. And so the ECSE is a 4-day boot camp, basically. It's taught by industry experts. Most of them are personal friends of mine. They're all dynamic speakers. They're incredibly knowledgeable in Wi-Fi, and I just can't recommend that enough. So be sure to go to ekahau.com/training and check out our training options. We'd love to show you what we've got available for different training options with Ekahau. So with that, I would like to open it up for questions. Jerry, do you want to kind of facilitate the Q&A stuff?
Yeah, and I have to apologize. I've been too captivated by this awesome presentation here that I really have not been. I've been kind of neglecting a lot of these questions. So we do have quite quite a large group of questions, so we'll try and get through as many of these as we can.
Yeah, and
First one,
one
actually.
more quick reminder too is if you threw a question in the chat, I've seen a bunch like out of the corner of my eye fly by in the chat. If you have a question you'd like us to address, then go ahead and put that into the Q&A tool, and that way we can basically mark them and say, know whether we've answered your question or not. So go ahead, Jerry.
So there's actually been some pretty good, let's talk about the chat for a second here. There's actually, I have been trying to kind of glance at that as I could, and I saw some pretty good dialogue in there about about duty cycle and utilization. What's your kind of take on duty cycle and utilization? Is it the same thing? Is it different? What's the difference there? How do we differentiate those? What's your take on that?
All right. So I think there's a couple of ham radio guys in the chat. So I'm going to fumble my way through this as best as I can, and I'm going to give some opinions. And if I'm wrong, I'm so sorry. You guys can correct me in the chat if you want. Here's how I see it. I see duty cycle as a measurement of one transmitter. We've got one transmitter, and it is transmitting at a certain, it's either on or off, right? It's either transmitting or not transmitting. And so out of that, you get a percentage of how often is that device transmitting versus not transmitting. So duty cycle to me seems to be a measurement of a single device's how often is transmitting, basically. Utilization, on the other hand, seems to be more of a measurement of an entire frequency. Like at this frequency, how often do we see things on that channel transmit versus not transmit? So that's kind of how I differentiate between those two. Ham radio guys in the chat, if you guys want to tell me whether I'm right or wrong, please feel free. Eric says nailed it. Yes. Okay.
Nice.
Thank you, Eric. So that's how I see it. Again, just like airtime and utilization, I think are very closely linked. I think duty cycle and utilization are closely linked. And when somebody maybe, doesn't explain it the exact same way that I do, I don't get mad. It's just, it's down to semantics. It's very specific stuff. And so it doesn't really bother me if somebody uses one term or another.
Excellent. All right. Next question we got here from Jonathan. How does multi-user MIMO factor into all this utilization talk?
Ooh, that's a good one. Multi-user MIMO is kind of a big can of worms, isn't it, Jerry?
It is. It is.
I think that in some very specific cases, let's see, was it at WLPC, the Wireless LAN Professionals Conference this spring, that Chuck from Aruba, I can't pronounce Chuck's last name, I'm not even going to try. Did he talk about multi-user MIMO and, does it work?
I thought it was 802.11ax, but, as part of that, multi-user MIMO was,
I think
of it.
I think he talked about multi-user MIMO in 2016. I think that's when it was. Multi-user MIMO in some very, very specific circumstances can yield you about a third increase in throughput. Ultimately, if we can transmit to multiple devices at the same time instead of having to transmit to each device individually, yes, that will decrease airtime utilization. That will save time on the channel. However, I think that for the most part in practice, multi-user MIMO is very difficult to pull off in the real world. And I think it does happen at times, but I think it's a tough one to pull off. So I'm sure some more qualified people could speak on that than I could, though.
Yeah, I think it's going to be an interesting one to keep an eye on, because 802.11ax also utilizes multi-user MIMO, and I think if I'm understanding correctly, some stuff I've learned recently is that even if you roll out, because of the fact that both of them take advantage, 802.11ac and AX both can take advantage of multi-user MIMO. If you have one or the other implemented, they can both utilize that multi-user MIMO technology. So let's say you have an AP environment. Don't quote me on this. I'm not 100% sure I fully grasp this yet, but this is.
Don't worry, we're literally recording it and putting it on the internet. So yeah, knock yourself out.
But yeah, something along the lines of with 802.11ax, you deploy 802.11ax in your APs, but your clients are 802.11ac Wave 2 and they support multi-user MIMO. You can still take advantage of that multi-user MIMO component, right? Because your APs support it, your clients do. They're not both 802.11ax client or radios, but they can take advantage of some of that technology that's shared between the two standards.
Very good.
Yep.
What else should we talk about? There's like tons of questions. We could spend 40 minutes on this, so I think we should keep going for a while, though.
Yeah, happy to nail through some of these. I know we're kind of already running over on time here, but we got still quite a few people online, so we'll keep going through these Q&A, and we'll get this all in the recording anyway. So yeah, let's kind of drill through as many of these as we can. How much airtime a device can reserve? A rogue device could reserve a lot of airtime. So yeah, that's an interesting one, right? Thinking along the lines of probably the nav timer, right? Of when a client is going to transmit, they can reserve a certain amount, a maximum amount of time that they can occupy that channel for, right?
Can you run that by me one more time? I missed it. I was
So,
distracted for a moment.
so the question was how much airtime a device can reserve, and there is a set limit. I don't remember what it is off the top of my head, but that's that nav timer, right? Is what I'm thinking.
Oh, how much can they reserve? I
Yep.
don't remember. That gets kind of into the weeds of, I think, probably like the CWAP, the Certified Wireless Analysis Professional book. I'll bet it's in there somewhere. But
But
yeah,
that is an interesting one because that is it has been known, at least in the past, of a certain type of attack on Wi-Fi networks, right? Where you have a rogue device that's setting a nav timer to basically tell all the clients to be quiet, and then it's going to transmit and use the medium for the maximum amount of time that the standard allows. And that way it would prevent everybody else from talking, kind of just makes everybody be quiet for that amount of time. And if it just continually does that, it kind of shuts up the whole channel and prevents anybody, either the AP or the client, from talking. So yeah, there is a set amount of time that can happen, but that can be even a type of malicious attack that can happen in the environment, or it could just be a bad client, right? Just a poorly designed, configured chipset or driver that is reserving the channel for a larger amount of time than it really needs, and it's not properly clearing the channel when it's actually done talking.
yeah, yeah. I mean, you could form a fake packet that just reserves a. I don't know. It'd be kind of interesting to kind of look into that and see. So, good question. I'm not really sure. I think you pretty much got it. I'm not really sure, but
Yeah, I don't know what the exact value is, but yeah, there is a set value that a client can occupy that channel for a maximum value. All right, so let's take the next one here. There was Alan, we talked a little bit about this already, but asking about a graph of utilization. So I think things have changed a little bit. I was trying to remember what Alan was talking about, but apparently we used to have a utilization graph that you could view in an older version of ESS. I'm not sure when that changed, maybe when we introduced like the RTFM view or something. But yeah, you can. This actually kind of ties into a few different questions around the sidekick. So everything we've been demoing today has been about the sidekick, just because that's the new hotness, right? But we've got a lot of customers out there that are using other hardware. You've got the SA1 adapters, you've got the Y-Spy or the Echo House Spectrum Analyzer that can accomplish very similar things. Maybe not as quickly and as high resolution, but will still work to be able to capture a lot of the same information that we're talking about, like spectrum channel power, spectrum utilization. So you can still do that today, even without the sidekick. However, you would need a spectrum analyzer to still do that. So like the Y-Spy that are compatible, as well as the Echo Spectrum Analyzer. However, if you just have like the SA1 or your internal adapter, you're not going to get this kind of information that we've been kind of talking about and going through on the spectrum utilization side. The airtime utilization, that's on the simulation, the planning side. So that you can absolutely do and plan and simulate. But to validate that, you're going to need some type of spectrum analyzer.
yeah. And David has a comment. He says, every time you call it the RTFM, I flash to the old school meaning. Yeah, David. Yeah, we knew what we were doing there. We like to have fun here at Ekahau. So Peter asked a question earlier. What is the fine black line on channel 11? So Peter, I think I know what you're looking at here. Well, there's one of two things that you might be looking at. These kind of square shapes, this is Wi-Fi scanning data. If you've used a Wi-Fi scanner like Wi-Fi Explorer or Wi-Fi Analyzer for Android or Insider or something like that, then this is essentially the same thing. Each one of these is a wireless network. For example, just outside my office is the Snow Shack, which is a snow cone place. Super convenient placement for me, by the way. So that's an indication of the networks, where they are, or the APs rather. And then this black line that you keep seeing pop up, it's kind of popping in and popping out there. That is current activity. And so the color is kind of a little bit of a historical look. Over the last 5 seconds, how much utilization have we seen there? Whereas that black line there is the real-time sweep. And you can turn that off if you want. So we could turn that off. But let's be honest, it's not as exciting looking.
You should actually turn off density one so you can really see that black line.
It's really fun,
Real time.
especially when something lights up that channel, but it's really fun just to sit there. This is real time what's happening in my environment. So there's some 802.11g, there's some 802.11b happening, there's some Zigbee, there's some Bluetooth, there's lots of stuff that's showing up here. And it's updating on my screen about 20 times per second.
And good news, to circle back to that question we had before about the maximum time that a client can use. I did, utilize Google here, and it is 32,767 microseconds is the maximum amount of time that a client can reserve that channel for.
Somebody want to do the conversion and convert that to like a human knowable time, because, well, I don't know. I can't even. A maximum of 32,767 microseconds. Hey, somebody in the chat, feel free to convert that to seconds for us. I'm sure it's just probably moving a decimal place is all we need to do. So let's see some other questions. Let's see. Ian asked, is there a separate video on why we shouldn't use channel 5 since we didn't mention it? Yeah, that's a good question, Ian. Basically, when you put, I'm going to draw a little bit here. If you put two APs on the same channel, they're essentially, them and all their client devices are going to essentially take turns talking politely. And so that's why you always hear everybody says in 2.4, just use channels 1, 6, and 11, right? Because those three don't overlap. Channel 5, on the other hand, partially overlaps with channel 6 and it partially overlaps with channel 1. And instead of politely taking turns talking, they'll just yell and scream. They'll just yell and scream over each other. So that's why that's called adjacent channel interference. That's why we always use 1, 6, and 11. You've heard that, the golden rule of Wi-Fi before. So Keith was kind enough to move a decimal place for us. Thank you, Keith, for doing that. That comes out to 0.03 seconds. That is the maximum nav timer that you can set. Thank you for that, Keith. We really appreciate you moving the decimal point for us. I just didn't know how far to move it. So Jerry, do you see a question that you want to tackle next?
Let's see here.
Keith says, thanks, Google.
So here was one from Oliver. Actually, this is more of a feature request. Will there be a record button for RTFM without doing a survey? So nothing in the near term, but that one has popped up a few times. So it's definitely on our developers' radar. And since I am on the product management team here, I will definitely take that back and, as a feature request and kind of add a +1 to that. I think that definitely would be a nice, useful feature to have that, where you could set that up for a period of time, record and come back. Now, I do know there's some workarounds for it. The continuous survey mode essentially will allow you to do that. It still requires loading some type of image or map on there. But yeah, theoretically, you could click the map, let it run for an hour or two, come back after lunch, whatever, click the map again, and now it's recorded all of that with its timestamps and everything. So you can do it. It's not obviously optimized or really designed to do that today. You don't have just a simple start and stop record button, but that's essentially what the continuous survey is doing. It's just tying all that data to a map as well as the timestamps.
Drew has a question here. Can you create custom applications and bandwidth requirements? I think you can. Can you? I should have.
Sorry, I missed that. I was looking at the questions. What was the question?
Can you create, question from Drew, can you create custom applications and bandwidth requirements? So
same kind of thing. Configure the profiles, and you can add in. There's you can create your own usage profiles, and then you can see there's a pretty extensive list. I don't think you can create your own applications, but you can see from a megabit per second standpoint, we cover pretty much everything possible. There's some just basic SLA, low, medium, high type things, and then there's very application specific type things in there. So you can add multiple applications to that profile. You can create your own usage profile that way. I don't think there is a custom application option.
I'm going to make up an application. I'm going to call it Zemu, because that's kind of,
one.
There we go, Zemu. We just made up our own custom application. And this application happens to require 1.5 megabits per second. So what I'm going to do is do an SLA of 1, and then I'm going to add 0.5 megabits per second on top of that. So boom, Zemu now is a custom application that requires 1.5 megabits per second. So that's how I would do it. What do you think, Jerry?
Yeah, it works.
New Ekahau product name? No, that's terrible. Forget that idea. No, moving on. Cool. Do you have another one here?
Let's see here. Can you expand how the RSSI level relates to how and where high utilization affects the environment? I'm not sure. Is that making sense to you, Joel? I'm not sure I'm quite understanding
Mm,
that question.
let's see. Let me see if I can find that one really quick in the list so I can read it. Where is that?
It was pretty far back at 11:25 on mine as the timestamp. So yeah, the
Oh yeah.
25 mark.
11:24, 10:25. That's right. We're in
Yeah,
different time zones. I'm like 11:25.
10.
I
Well,
still can't find it.
while you're looking for that, let's see here. We've got another one from Chad. Is there a percent where packet loss becomes a bigger issue? So yeah, that's
Hmm.
going down a whole other, variable to consider, right? Besides utilization is going to be packet loss, right? And that's more further down the line, right? So packet loss is going to depend on a lot more variables at more the application layer and how many times it retries and different things. So packet loss gets a bit tricky and a little out of the scope of this webinar. I don't know. You got any thoughts on that of what's an acceptable amount of packet loss for typical application usage?
I'm going to throw a guess out there, Chad. I'm going to say once you start hitting about 20 to 30%, I'm going to start kind of being a bit concerned and maybe checking into that to see what's going on. That is just throwing a number out there, though. I think it
Yeah,
depends on the application a lot and
exactly.
how acceptable loss is to that application. So it really depends. I've used some applications that just have excellent net code that can just recover from like the most ridiculous circumstances. Like for example, back in the day, I used to play Halo 3 on a dial-up connection, and it was a bit tricky, but it worked. Like it was amazing to me that it even worked at all. So some applications are really acceptable of adverse network conditions. Zoom, for example, Zoom does an amazing job in adverse network conditions, whereas other video conferencing and web conferencing tools that we've used aren't quite as acceptable, or they don't accept things as well. So it really depends on the application, but I'd say 20 to 30%.
Well, here's a good one for you, Joel. Are the classes and certifications for Ekahau recognized as the same level as the CWNA?
Ooh, that is a great question. I'm going to say yes. I think so. Now, don't get me wrong. I don't get me wrong. I really love the CWNP program. Jerry and I were both CWNEs, and I learned a ton in that program. And I can't even begin to express how valuable I think that program is. But the ECSE is we've got thousands of people certified around the world now. We can hardly keep up with demand for classes. And what I love about that class is it's not so much of a here's how to use Ekahau class. It's more of a here's how to design and deploy and deploy great Wi-Fi class. And so tons and tons of great pieces of knowledge in there. I learned a ton, and I think that it is becoming even more and more and more recognized in the industry as it builds steam. So I highly recommend that. Maybe I'm biased, but literally I took the ECSE before I even worked at Ekahau, and I was blown away. So there you go.
Yeah. Matt, along the training question here, Matt asked, does the Ekahau training cover the Wi-Fi analysis tools in ESS, not just the design side?
Oh, wait, can you read that one more time? I was reading a question, was not listening. I should have been listening.
Does the Ekahau training cover the Wi-Fi analysis tools, not just the design side of the tool?
Oh, that's a great question. So you mean like the real-time frequency monitor and using the Sidekick and stuff like that? Do you think that's what he means?
I think that's exactly it. Yeah.
Yeah, it definitely does. Our ECSE trainers spend quite a bit of time actually on spectrum analysis, and not just how to use it, but the theory behind it, the why, all that stuff. So I'd been doing spectrum analysis for years when I took the ECSE, and I felt like it expanded my knowledge and understanding of spectrum analysis quite a bit. It was very, very, very good.
Well, I know we set this webinar up for 45 minutes. I think that was a mistake on our part. Obviously, it's a very popular one. We're already well past that 45-minute mark, going on well beyond an hour here. So I want to wrap this up, just being mindful of people's times. I've got two
That's a good
more
idea.
questions. picked out here, and then we'll shut it down here. And if there's any other questions that we missed here, feel free to ping either Joel or myself on Twitter or email. I'll be happy to try and get those addressed. But yeah, let's talk about this one here. I think was an important one, and I want to make sure that we did nail this down, because I do feel like you bring up a good point here, Andrew. He said maybe we missed it, but how do we address excessive airtime utilization and more access points on different channels in the area to distribute the load? If we have heavy Wi-Fi usage, is it better to have channel overlap than it is to have high utilization? And that's a pretty, I feel like, a loaded question, really good question. I don't know if we'll be able to completely dissect that here during the Q&A portion. What do you think, Joel? What's your take on some of that?
I was about to say that one's all you, buddy.
Nice. I thought I'd throw you a little grenade there.
Yeah. That's a pretty good grenade.
So here's a couple of kind of tips, right? So we kind of jumped around a little bit, I feel, and maybe didn't tie everything together as best as we should have. But yeah, around excessive airtime utilization, a couple of things that we can use to address that is going to be starting on the configuration side, right? What is our minimum data rate set to? Those are the easy ones, right? The low-hanging fruit that we can start to do, lowering the number of SSIDs. All of those kind of things are going to alleviate some of that congestion in the air that isn't necessarily needed if we design it and configure it properly. So we can start to kind of eat away at some of the management traffic and things like that that's maybe unnecessarily eating airtime utilization. Beyond that, then we're looking at channels, right? What does our channel usage look like? Are we using 20, 40, 80 megahertz wide channels? Can we get better channel reuse if we lower those channels to reduce that congestion and that utilization by separating out those channels and lowering our channel width, right? Then beyond that, we may need to look at adding additional access points. If we have more channels available, but our utilization is shot, maybe we need to add additional APs, put 2 APs in an area, put 3 APs in an area, as long as we have the channels available to that, make use of that spectrum. So there's a lot of things that we can do there, starting with the low-hanging fruit, the easier, less expensive options of channel configuration type things, data rate configuration, but then moving into physically adding additional radios to lower that utilization per channel. But yeah, I think the one piece that is an interesting part of your question there that I didn't answer was around what was it about channel? I lost the question here, but about channel overlap, right? So yeah, my rule of thumb, and this I got from Keith Parsons, I think really is always a good one to apply, is use the widest channels possible while avoiding co-channel interference. As soon as you start introducing co-channel interference, you need to back down your channels. So thinking of 5 gigahertz specifically, right? Start with maybe 40. If you start to introduce co-channel interference, you need to back down to 20, right? Maybe you can pull off 80 if it's a very, minimal AP environment. You have very dense walls, things like that to separate that out, but we don't even want to talk about that, right? 20 and 40 in an enterprise environment is typically all you're going to be able to utilize.
Yeah, my rule of thumb is 20s by default, 40s if you can. That's typically, and a couple environments I've gotten away with 40s. Typically, though, we're looking at 20s, 20 megahertz channels.
So the last question I had picked out here was from Curtis. Do we have a good source for chipset information? What's your go-to, Joel, to find out device chipset information? The first one that comes to mind for me is the clients.mike Albano. Not specifically chipset information. Well, I guess it is kind of. It doesn't focus so much on the chipset as it does the device. But this is the best database that I found of highlighting the device's capabilities, especially when it comes to spatial streams, transmit power. What about you, Joel?
Yes, really clients.mikealbano.com, which hopefully is now on the screen, hopefully.
Yep, I see it.
This is my go-to resource. Specifically, if you click this little pop-out link up here, it'll open that up in just the direct Google Sheets view. This is a great resource for looking at what channels it supports and what PHY types it supports. So, take a look at this. One curious thing that I did notice is, it looks like it's still loading, so I can't scroll down, is I put my Nokia 6.1 in here, and the Nokia says that it supports 802.11n, but it supports channel 144, which I believe is an AC-only channel. So, something interesting going on there. That's the first place that I would go. Second place, what was the second place you were thinking of, Jerry? I think I know what the answer is.
I don't know if I had a second. Well, I mean, there's the wiki pages that have all the chipset information,
Oh yeah.
wiki dev. But yeah, you can find if you know the chipset of the device, you can do a search and find out all the details of what that chipset is. The scary thing about the looking up the chipset is I've found some of that stuff to be misleading because the manufacturer might design a chipset, for example, as a two spatial stream chipset, but the vendor may implement that as a single spatial stream, meaning that they only hook up one of the two antennas. So that's where we need to know what the actual device is advertising its capabilities are. And that's where this Michael Bono database is I think, in some sense, a better picture because this is actually what the device is advertising its capabilities are, not what the chipset manufacturer says the radio chipset's capabilities are.
Yeah, yeah. So, for example, my Nokia 6.1, it might be 802.11ac. I need to go look at the specs. I thought it was when I looked it up, but it's reporting that it's only 802.11n. That's the 5 type it supports.
Yep.
And which is interesting because that channel 144 thing there. So a little bit of a discrepancy. I think ultimately the answer is know thy clients, know what you have on your network and know what their capabilities are. And it's going to take some legwork to figure that out. So anything else, Jerry? Or should we call it good?
I think we call it. We still have probably about 40 more questions or so, I think, in there. I apologize for not getting through all those. Obviously, this is a very popular topic, and I appreciate everybody sticking around as long as you guys have and bearing with it. But I'm going to call it just for the sake of everybody's time here. And yeah, if we didn't get to those questions, like Joel's got up on the screen there, feel free to shoot us a message on Twitter or email. And yeah, I just want to thank everybody for attending today's webinar. If you have any other questions, please contact Joel or myself, and you'll also be receiving a follow-up email within probably 24 to 48 hours after the webinar ends here, and we'll send you a link to this great session. So yeah, on behalf of Ekahau, just want to thank everybody once again for joining, and hope you guys have a great rest of your day.
Thanks, everyone. Bye now.